Bene, scusate il ritardo. So sorry for starting late. This is the last lesson. I don't know if I'm able to finish in time, but in any case, you have the slides. So we left last lesson with the rise of the World Wide Web, and in particular, it was based essentially on three things. First of all, the idea of representing a document with a text file with a markup language. The second is to have a browser that could visualize this page and also images and dialogue with a server. And the third is a server and the development of a new kind of protocol, the HTTP protocol, which was essentially a very stripped down version of something like FTP, because in FTP you have to establish two channels, one for sending commands and the other for receiving data. Okay, and so the connection was kept alive for the whole session, while the idea of HTTP is very simple. There is a handshake part in which the server and the client establish the connection. The client sends then a request, a get or post request to the server, sending also cookies, as we shall see, so some small pieces of information. The server treats the request. It could be for a static page, it could be for a dynamic page, it could be could need the running of some program, sends the response and closes the connection. So it is essentially the connection is made in some sense atomic, even though the client continues to navigate the same so the chain of pages that are part of a site, the connection is closed at each request. This is clearly the first protocol. Now we have possibilities of keeping the connection alive in order to, for instance, populate the page with the things coming from database. But the essence of this protocol is this one. And the explosion of the World Wide Web, which is a different things from internet was already existing, led to the disappearance of a lot of services like America Online, also Microsoft Network, which were based essentially on connections point to point from clients to servers using modems essentially. And each of them was offering services like, for instance, a chat or email, which were closed essentially. I remember that, for instance, also the DECnet, the network of Axis, was a closed system. So, and also BitNet, the network of IBM servers. So essentially, in these cases, you could send a mail from one user to another inside the service, but not to any users of any system on internet. Clearly, bridges were then developed in order to send, I don't know, emails from BitNet to DECnet to internet and so on. And but in any case, speaking of say services that could be accessed by browser, this was a real revolution because in principle one could do anything using a word a browser. And this was also seen as a liberation. So, for instance, the Electronic Frontier Foundation was founded just to defend internet and www users, but still something was missing. This was the era in which the internet, World Wide Web, was seen essentially as a way of sharing information, not as a market. And so, for instance, it was completely missing a payment system, especially for small payments, and a way of searching for information. There was Gopher, but it was quite limited. So the first answer was Yahoo, for instance. Yahoo had a nice interface, but which was populated by hand, so maintained by a lot of people working on this, and it was essentially based on, say, making links to whole sites rather than pages, clearly, because since it was done by hand, essentially they listed the sites dedicated to sports, to arts, to computers, and so on. And the first revolution in this sense was Alta Vista, again from DEC, the Vax house. Alta Vista was the first one which used the bots, in order to navigate the web and take information from pages, and following pages reconstruct the whole web. But the problem with Alta Vista, which was clearly a big revolution at the beginning, but after, say, just 1 year, it became essentially useless, because people trying to promote their sites, especially porn sites or sites selling something, were developing, since the indexing of a page, the importance of a page, so the ranking in which it appeared, was based on the content on the page. So if you were searching, for path integral, it listed all pages containing the word path integral ranked with the number of occurrence of path integral inside the page. So essentially, people started to put a lot of terms which were searched commonly in transparent fonts, or very tiny fonts, or masked behind some image, so that they were indexed at a high rank in Alta Vista, since it contained a lot of information, or a lot of terms, but actually it was showing a completely different content. For instance, using images, so that the robots could not read what was read by humans, essentially. And so in 98, Alta Vista was quickly replaced by Google search, which developed clearly quite interesting piece of software. First of all, the database in which was stored all information, and the PageRank way of assigning importance to a page, in which the page were classified using what the contents, but the importance was given by how many links arrived to this page. And this was a way of exploiting human intelligence, because generally links are set up by humans and not by computers. And so the idea was to exploit the information hidden inside the network of connections among pages, and use it to get this service. Clearly, another interesting point, which is not covered here, is the algorithm for traveling the web pages. So the robots by Google essentially follow with the pages with a certain probability, or jump to another random page with a given probability, and this probability is adjusted in order to navigate quickly the web, which was clearly exponentially growing. And then clearly the other things that Google invented was the mechanism of the revenue. Essentially what we shall see in a moment the pay-per-click. So essentially, it was getting money from advertising according to the number of clicks received by links. And after this, as you know, Google bought and adapted a lot of other services based on a web. So Maps, Earth, Books, Google Docs, and then he developed his own browser, Chrome, and then Android. So the other service which was missing was payments and markets, and so you see that in quickly Amazon appeared, and then eBay, and then PayPal, and clearly Google, which was getting a lot of money from this pay-per-click, which was also offered to other sites, so you could include, you still can include Google advertisement in your page and get some money from it. And clearly, customers are also identified by cookies. Cookies are a way of making the HTTP protocol, which is stateless. It means that it has intrinsically no way of knowing who, where you come from. Actually, in the heading of the HTTP connection, there is a field which says if you click the link on some page, so where you come from if you click a link. But if you type an address directly, you don't see it. And so you cannot easily track how the pages of users, while cookies can be used for tracking this, and also for, say, keeping the connection alive. They're not always bad, the cookies, because if you are making transactions on a site using cookie, the site can know that you have in your, say, shopping bag already some amount of items, and then you can add others and so on. And this essentially is also connected to the idea of dynamic web pages, because the first pages were just static. So you wrote something, and that was the pages. Then the form was developed, the form extension to HTML was developed, by which you could insert something and pass this information in the URL with a question mark and then fields and so on, inside the get or post query to the server. And in this way, you can get data from a database. So you have to build up the page dynamically, because the content of the page came from a server. So it was developed a way of launching a program on the server, passing information from a form to this program. The program could, for instance, get information from a database. Then it returned the web pages built with variable data, and then this was returned to the client. And this is called a common gateway interface. Then the next step was to include this ability of elaborating information directly on the server. For instance, PHP was integrated, could be integrated on the server. Also modules for with Perl, Ruby, and so on. And finally, for instance, the last one, which is the most used, is Node.js. For instance, Google Docs, Google Apps essentially are a Node.js application. And so since the browser was so important, it's started to be used quickly. clearly we are speaking essentially of graphic browser, but for instance, in the university at that time, it was quite used also Lynx, which still exists, which is a textual browser to be used also on terminals, say. But for users, the general user, clearly they prefer Mosaic, which was then made commercial by Netscape. Microsoft at first ignored completely internet. It was relying on his Messenger, but then suddenly realized that the browser could replace a whole operating system, and so it reacted developing Internet Explorer, or Internet Explorer as you want, which was one example, and also gave rise to a court appeal, because it was given for free with Windows, and was installed by default as the default browser with Windows. So while Netscape was sold, you have to pay in principle to use Netscape. So clearly it quickly replaced the, as you can see, the Mosaic. Here in the green is Netscape, which was quickly replaced by Internet Explorer, and only after some say problems with Internet Explorer, also legal problems, it started to be replaced by others browsers. Clearly now Internet Explorer has essentially disappeared, and clearly there is interesting path, because what Netscape developed was separation from the rendering machine and the browser itself, so that the rendering machine could be used for other applications. For instance, Thunderbird, the email client, was essentially written as a kind of web page running on the machine that also was used for Firefox. So essentially, all the interface of Firefox Thunderbird was developed using essentially HTML, including the menu, but not the menu inside the page, the menu of the application. And there was, so you see, the other important contribution was in the Unix field, in the Linux field. We shall see Linux in the following, but KDI, which is a German enterprise, developed a common desktop environment, which now is used in Linux, for instance, and also its own web engine, that was used to develop the Conqueror browser, but which is now used by Apple and also by Chrome. So essentially, Chrome and the Safari browser from Apple use the core of this browser, of this web engine developed in the Unix world, and which is called now WebKit. No, where is it? Here it is. And also Chrome use this. So we said that Internet Explorer was sold embedded in Windows, and this brought to this dispute, because Windows was accused of illegal competition. So essentially, Bill Gates was convinced to retire from essentially Microsoft, and at the end it was ruled that Windows should separate Office and Internet Explorer, and finally, okay. So remember these dates, essentially 1998 to 2000. which essentially corresponded also to the explosion of the internet bubble. You can see how the rise and fall of quotations made the people millionaire in some days and also poor in other few days. And so there was a time in which essentially one could got a lot of money just say selling an idea without developing anything. But Linux essentially Red Hat become public in this date, and this was also the date in which Linus Torvald become a millionaire because he was given some stock account from Red Hat. But after a while, the bubble collapsed and a lot of enterprises say failed. In the parallel history of commercial software was that about GNU, which is essentially this movement from the electronic frontiers, free frontiers, and so it started with Richard Stallman, which abandoned the MIT and found, so it was working on Lisp, as you see, Lisp still start to appear. And so he decided that he had to write a complete operating system, clearly deeply inspired by Unix. And so GNU means is a recursive acronym. GNU is not Unix. And so he developed, he was at first it decided to write the whole system. Then he found that a lot of components were already available. For instance, the X graphic system developed by MIT was free. The Tech scientific markup program was free, developed by Donald Knuth. He wrote Emacs, which uses a Lisp as a script language, and also the first C compiler, and then the other utilities. And but he was not able to write down the kernel, the hard, which was planned to be a microkernel, because essentially, I don't want to enter this question, but the idea of a kernel, which is the core program of an operating system, in the 70s already, was that it should not be a monolithic program, just one program essentially, because it was too dangerous. It should have a system made by different processes that communicated among them, which is called the microkernels. The problem with microkernels is this, it is that it is quite difficult to have something which is affordable, because clearly if messages arrives out of order, that can be a big mess. So Linus Torvald, who was a student and both one of the first 386 computers, and so he started wanting to write just a program to connect to a modem and to the server. Then he was studying a very simplified Unix kernel, Minix. He was not satisfied, so he started to write down a complete operating system, a monolithic one, so just a single program. And so he actually was able to write it in 3 months, and then he started adopting, porting all the utilities GNU. He wrote down his own version of the C standard library program, and he distributed it freely using a newsletter, so a public repository. And so immediately a lot of other developers started to write down device drivers, adapt them, the distributions started to appear. Distribution means that you can pack the kernel with all utilities and also possibly develop a way of checking if some piece of software is compatible with the others, and have say packed together all programs tested to work in say version of the operating system, having a way of downloading the new versions of utilities. So the things that have been then copied by Microsoft, by Apple, and so on, with the different stores and so on. And so you see that different distribution appeared. Slackware, which was, I think, the first one I used, in which you had to compile everything by hand. Then Debian, Red Hat, which was a revolution because it also Debian, they used this package system, so you didn't have to keep track of all the things and so on. And another protagonist of this revolution was Eric Raymond. He was more in the philosophical field, but he wrote this Cathedral and the Bazaar text, which was in some sense the manifesto of this movement. And for instance, he compared the development of Emacs and GCC, which have been developed by Richard Stallman, using a standard development process. I mean, having a team of experts working on a program, a small team of experts working on a program, and releasing only major improvements, while the Linux kernel is an example of this bazaar model in which everyone could see live the development of the software, could participate. Clearly, there have been ways of avoiding people destroying everything, but essentially anyone could fork its own version of the system, make any development he wanted without asking permission of using this software. And clearly there are success and problems in this approach. For instance, Wikipedia is one of the biggest examples of this bazaar model, but clearly for large complex program, like for instance, I don't know, developing a browser, still the Cathedral architecture may be the one important. In the meanwhile, the wiki idea was developed by Ward Cunningham, essentially exploiting the fact that dynamic web pages could be also written by users, in the sense that you could have a form in which you could write down the text using some markup language, and this could be then stored in some database and served to all others. So the idea was this, so to let people write down so contribute to a common website, instead of having its own developing the personal web pages, as was done at that time. He could join together. He developed these camel case ways of making links. So you just had to write down a camel case word, and it was converted to a link, and it was open to everybody. Clearly, this gave origin to Wikipedia. Wiki means quick in in Hawaiian, I think, language. And so this is Wikipedia. Also, Wikipedia used the camel case word, but now essentially it uses another syntax. And at the beginning, it was only text. So with the standard markup, say that I think it is called the markdown, using asterisk for bold, underscore for italics, and so on. Now you can edit Wikipedia using a visual rich text editor, but this was possible only after a certain version of the browser. And so you can see that also Wikipedia has grown exponentially, and it was essentially also a revolution, because nobody could have forecast to a success of something that an encyclopedia that was written by everyone. So with say a very democratic control, I mean that everyone can alter a page, but since there are so many people looking at modification, you can be essentially certain, unless it is a very remote page, that your revision will be checked and eventually controlled. Parallel to the browser war, after a while, there was the server war, because clearly the server adopting a server meant to have a whole operating system behind. So essentially, the the war was from one side Microsoft, which was selling its Windows NT for a server, and clearly with a server Windows web server, which had some problem, remember, because since a server generally runs for I don't know, months or even years, continuously accepting requests, forking, and serving a request, and then shutting down the spawn, the process, and so on. If you have any minimal memory leakage, I mean, some part of memory allocated by one of these forking processes not released to the system, after some, I don't know, some months, some week, or some year, you have the whole memory filled, and so you have to shut down the machine, essentially. So I remember, for instance, here in Florence, there was a big web server, which developed a way of shutting down periodically by electronics the servers in order to clean the memory. While in the Unix world, which was then ported to the different operating system, the leading server was Apache from NCSA, the same enterprise who developed the Netscape. And Apache is a pun for a patch, because clearly it was continuously patched. And finally, the database was the MySQL database, which started as a proprietary database, then was released, open, and then passed to Oracle, which also developed its own database, and so on. So essentially, the suite for having a web server was the server itself, a scripting language like Perl or PHP, and a MySQL server. And clearly, you also had to develop a way of having computers serving this system. And so first of all, you use the very expensive server like mainframes, but at the end, the solution was that of Google. So to have a very cheap and out-of-the-shelf computers, I think this was the first Google server. So you have just motherboards and connected by some fast giga internet connection, hard disk, but you just store all of them in some rack, and since it had a failure rate, there are so many that at least one every, I don't remember, some few minutes was failing. There was a rack of, say, spare motherboards, and people that continuously passing and replacing the failing motherboards. Clearly, you also had to develop a way of managing all of this. Each server ran Unix, Linux essentially, and Google developed this map reduce, which is directly inspired by Lisp. The idea is that if you actually, it was developed by Apache and then adopted by Google. So suppose that you have a database with 5 rows and with 2 columns, city and measured temperature, and you want to find the maximum temperature. Then you can say distribute the process to 5 processors. Each of them has the task of finding the temperature for just one city, and so this is the map operation, and then you reduce the results, combining them and producing the response, and this is how this works. Clearly, in practice, you spawn more than 5 processes. The first one which answers is accepted. The others could answer, but if they're late, they are thrown away. And also, from the electronic point of view, there was also a kind of war of processors. From one side, Intel, which was essentially pushing the limit of CISC processors. So essentially, since a CISC processor, as we already said, they used mainly microcode instructions in order to mimic complex instructions with simple electronics, relatively simple electronics. And this meant to have the processor running at a higher speed than the rest of the system. So essentially, they started to push the limit of the speed limit more and more and more. Clearly, since this meant also having less defect on the CPU, it also developed a way of selling defective or downgraded chips. So an i3, i5, i7 are essentially the same chip, but sold at different prices according to the number of units working and so on. But this also meant having a lot of heat dissipation. If you have seen a processor or a motherboard of the 2000, you could have noticed a very large fan, sometimes with a cooling system using water or other system, because it was essentially dissipating a lot of power. While the other approach was that of AMD and then of also NVIDIA and Apple and so of developing a multi-core system with essentially a RISC approach, a restricted instruction set, so that and also GPUs, so which is the idea, the extension of the FPGA array, and so essentially the idea now, also for a complex system like the M1 or M2 and chips by Apple, is to have in the same chip very different things. For instance, memories and also GPUs and CPUs and neural networks and say caches, all inside a single chip. Clearly, you cannot expand this, but you can make things quite powerful and cheap, and also to reduce the time of communicating among different parts of the memory. And the other important revolution, in some sense, is to push virtualization at maximum. Virtualization is not a new thing, because, for instance, IBM developed in the system in 370s this technique also for the machine itself. So essentially, you had the virtual machine which could run inside the virtual machine. And so, for instance, you could test the whole system inside a virtual machine before replacing the operating system. So in this way, you can be sure that when you, say, update an operating system, you have already tested everything inside the virtual machine. Clearly, a virtual machine can be of different types. You can have just emulation. So you implement ways of processing the instruction of a CPU using another CPU. So, for instance, if you are interested, you can now run a VAX VMS system inside any PC, just installing an emulator, and then you can load everything. But clearly, this is quite slow, because you have to translate either at the compilation time or at running time the native instruction inside in a different architecture. Virtualization generally means using programs written for the same CPU in which it is running. So you have just to shade the call to the operating system or to the devices and intercept them, and having them served inside the virtual machine, while the direct call to processor could just be fulfilled. So essentially, the speed is almost the same as the native system. And this is, for instance, used, for running Linux on Windows, or Windows on Linux, and Linux on Mac OS, and so on. And okay, let's come back to the social part. One, clearly, the increasing power of CPU, of memories in the, say, market computers, and the speed, increasing speed of Internet of connections, finally made possible to have a system serving, for instance, videos. So, and this made possible what is now common things, that to have computer enterprises interested in buying the movies or producing new movies. So this started in '89 when Sony bought the Columbia Pictures from Coca-Cola. So it was always strange that Coca-Cola was interested in Columbia Pictures, so essentially in the archive of movies. But then Sony made this explicit. And for instance, another revolution was clearly YouTube in 2008, in 5. So after 11 months, I consider that Google bought it for $1.6 billion. And it was really a revolution. I remember when it appeared, I thought that it would have so expensive to have the storage of all these videos that it would never be possible to make a revenue from this, and clearly I was wrong. And another, for instance, was another different approach was Netflix. We started renting DVD, but then made the transition to streaming, while blockbusters, for instance, I was never able to do, and clearly it failed. And Netflix at the end started, as you know, to produce its own shows, and clearly the same then was done by Amazon Prime, that began as a way of, say, making a more, say, fast delivery of things, and now is serving any kind of service, Disney Plus, and so on. So, as I said, the idea of having a possibility of uploading or writing down web pages was seen as another kind of revolution called the Web 2.0, in which the web was now, this was a term coined by publisher Tim O'Reilly, but the idea is that the main part now of the web is not produced by some service or some, say, big enterprise, but by user itself. And so, for instance, Facebook is one, but it was anticipated by other services. And clearly, on the other side, there is a Wikipedia, and or YouTube also is an example, like any other social media, which is now the main source of information, especially for databases. But also, when you look for some information, you essentially get the answer from things written by other users rather than by top-down enterprises. And so you see the histories, and the one that you know, YouTube, Facebook, Instagram, TikTok, and all the rest. I'm not going deep on this part, because clearly it was it is a huge part. But you can consider that in this way there is a strong influence of the recommendation system of the platforms, because when you look for information, for instance, in Facebook, but also in any other social media, you receive responses not based essentially on, as in Google, on links or contents, but rather on the profiles of so what other people had visited, and how near you are to other users, essentially because you chatted with them or you visited the same sites and so on. And this is a possibility of developing this echo chamber, in which you listen only to people that thinks like you, or knowledge bubble, in which you find only the contents that already have been, say, approved or selected by your community. And so essentially this is a completely new way of seeing how information is processed in internet. Clearly the web also influenced the programming languages, because just consider that in 1995 Java was developed by Sun as a language for application, robust, based on a virtual machine, which then was just compiling just in time. So the idea was to have something that could be written and then instantiated on different kind of hardware, so that the same program has not to be compiled for all different platforms and all different versions. You have just to install the virtual machine, and then it received a program in an intermediate form, and then it on the fly could compile in machine language, or something near to machine language. The problem is that Java is not interacting well with the operating system, so that essentially it has its own feel and appearance, not complying with that of the operating system. So you can see a Java program, you can discriminate it. Say for instance, when you look for how to load the file, so the file browser interface. And it was also thought to be the way of embedding programs into web pages, but again, it had a lot of problems communicating with the server. On the other side, Netscape developed the JavaScript, which was essentially embedded inside the browser and which could manipulate the document object system, and so the content of the page and the structure of the page on the fly. The name JavaScript was chosen because Java was quite known, but it has absolutely nothing to do with Java. It is not a scripting language in Java. It is a different language. It is actually, its real name is ECMAScript. And so essentially, at the end, Java had to interact with JavaScript in order to manipulate the page. And finally, the Java support for the embedding in page called applets was dropped. So now Java is only used for embedded system, essentially, while still it is taught to in every computer course. And so you can see that you have, so in this figure, for instance, you have the time evolution in the last 20 years of several languages. Clearly, database languages stay there, and HTML, CSS stay essentially there. Java, there is a rise and fall, while JavaScript is still, say, essentially continuing. And clearly now, for instance, there is Python, which is so taking place as a scripting language. Then clearly, the increasing capabilities of browser made it possible to have also software as a service. Instead of buying, say, Office, you can just make a subscription or having it for free and use a web service. So clearly, the first big offer was that of Google, for instance, Google Docs. And so, for instance, Google was able to offer, say, essentially to use a browser as an entire operating system. The Chromebooks are PC personal computer with Unix, Linux, that only run a single application, a browser, and on the browser you can have any kind of service. And now you know that there is a whole suite of application. This was imitated by Microsoft, for instance, which now is proposing Office on the web. And this was made possible by a combination, say, of possibility of describing data using a syntax similar to HTML, which is called XML, the JavaScript that could, say, download just a piece of information and alter the web page and insert it in the appropriate page, in the appropriate part. And so essentially this is called Ajax, with again a marketing name, I think also by Tim O'Reilly. And Chrome, which is the browser developed by Google, is by far the biggest, say, the most used browser, because you can consider that essentially it is also Edge, the browser by Microsoft, is essentially Chrome. And at the end of it is the WebKit, which is also used by Firefox when it has to be run on an iPhone or iPad. Also Safari, all of them are the same. clearly, the major transition in the second decade of the 2000 is the essentially replacement of computers by smartphones. And you can see that the percentage of, say, browsers now is that the majority are from, say, smartphones or iPad. And this also means that the content of pages had to be adapted. And so essentially, this was the idea of dynamic web page, which the formatting of the page is different according to the browser that used. This is mainly done by using the cascading style sheet, not redrawing the page by JavaScript. Just saying that, okay, if the screen is such a proportion or such a dimension, you have to put things in a different way. And Android was essentially the response by Google to the iPhone, and actually Steve Jobs was extremely, say, complaining with Google about this. And okay, Jobs was also asked to become the CEO of Google. So, and so there are competition, but also strong interactions among Google and Apple. And clearly, this meant also that the design of phones changed, because for instance, we saw the disappearance of Nokia, which had its own operating system, Symbian, but it was, say, not upgraded, could not sustain the competition of modern operating system. So then Nokia tried to adopt the Microsoft portable operating system, which some people say that it was quite good. I tried on a Nokia, and in my opinion, it was terrible. But at the end, the look and feel are copied by that of iPhone. I actually prefer Android with respect to the iOS, but this is a matter of taste. And as you see that also now Google is copying the iPhone, for instance, by removing the audio jack. Clearly, another revolution born in Apple was that of the iPad, tablets, and because it started with the Newton, which was a failure, but then also the other type of, say, tablets have been developed. And clearly, again, you see that there is a heresy by the Xerox Palo Alto, but clearly the big revolution was the iPad, which essentially introduced a different way of, say, dealing with portable devices. But almost immediately, Android tablets came out. Clearly, Android was first designed for phones, so it had some problems, for instance, in having the rotated proportion of the screen. And for instance, the Kindle by Amazon is essentially again an Android with a custom program just to read the books. And so now you can find computers, or at least a CPU, everywhere, because with this mass production is much more cost effective to embed the processor with some general purpose chip like programmable field gate array, and instead of developing custom electronics. So you put much more power that you need, but cheaper in a card. Then you program by software the electronics essentially, and you have anything you want. So cars, washing machines, modems, phones, and so on. The problem clearly is that since all this has a CPU and the power of a good PC, it could be hacked, and there is, for instance, attacks aimed at things like washing machine, which have not been at first designed with security in mind. Clearly, essentially most all of them use Linux, so essentially you can see now that Linux is the most adopted operating system in the world, not for PC, but for all the rest. Android clearly is Linux, and but still there are hacking and attacks aimed at taking control, for instance, of washing machine, just to say, for instance, run denial of service attack. And another big problem that we are now facing, for instance, is the documentation of the evolution of all of this, because there are a huge number of sites, web pages, which at certain point disappear, and no standard way of recovering them. So, for instance, Google now stopped the cache system. Up to 2 or 3 years ago, you could choose to see the old version of some page, but now it is not possible. There is Internet Archive, which is storing a version of pages. So, for instance, I was able to recover some of my old contribution to the web just looking at the Internet Archive. And there are clearly other ways of archiving things, but clearly for platforms like Facebook, YouTube services, you don't have this way of recovering things. And also these platforms where are now, say, losing, so the old sites are losing importance. And so, for instance, you can read this article on the post on the end of internet site. This is just the Homer answer of building a web page with essentially gave no information. It was just a collection of moving GIFs. And another interesting article by the Post was the debate about this image. There is a nice history of how a single image and a single question: do you see a red, gold and white, or a blue and white dress here? And it is nice to read how, say, essentially socialware, BuzzFeed essentially, was able to have to involve millions of answers. And this was also an occasion with which, for instance, Facebook started to put filters on this kind of phenomena, because they were afraid to lose control of users, and so not being able to control this self-organization of users. And so, for instance, it is said here that Facebook changed the algorithm in order to keep the bubbles that we already spoken about separated and not to have them percolate. Because it did not want to not be able to control what users does on this social network. So just arriving to the last year, we also have this blockchain technology, which is an interesting way, in my opinion, ways to contribute to heat pollution of the earth and throw away a lot of computer time, because the idea of this blockchain database to have a distributed database without no single storage, so anybody can duplicate and check for validation of a transaction recorded on this tree. But their way of avoiding a lot of transaction added to the same chain, which clearly could constitute a problem, because since you can have several copies of the database, but you want to keep all of them synchronized, you have to have a way of adding transactions only at a certain rate, not more than that. So how can you avoid having a transaction added at any rate? It is essentially based on the problem of finding again solving a difficult problem. We have already seen something like this in the public key cipher, in which the problem was to find two big prime numbers whose product is the one that you serve. In this case, it is based on the hash. So a hash of any document is a number obtained by combining in some way the information in the text. A good hash is essentially a chaotic system, because you need to have a variation of a single bit in your document reflected by a complete variation of your hash. And clearly you cannot have a hash as large as the whole document, otherwise you lose the concept of hash. So you have a compact certificate of your system which changes completely anytime that you change just a single bit. And the blockchain require the hash seen as a number to be below a certain threshold, a certain challenge, which this is called a difficulty. So essentially you have to try different way. You can add a small number, so a number essentially. You can this nonce, these things like here. So you add this number, you compute your hash, and you have to repeat this until you have the resulting number below a certain threshold. So essentially you have to try, there is no way, since it is widely chaotic, you have no way of performing an optimization, like for instance simulated annealing, gradient descent, and so just brute force. And so you have to waste a lot of computer power in order to try different nonce until you have the right hash. And at that point, you can add it to the blockchain. And clearly, this means that there are, since blockchain is also used to produce bitcoins and other electronic money, there are a lot of computers nowadays just wasting computer power, just trying to find the good nonce in order to add the things to the blockchain. And so this is a kind of crazy things, in my opinion. Okay, clearly another part which is the end of my talk. I am, but I'm not sure being able to present it in a good way, because still we have some 40 slides. Is the field of artificial intelligence, which is again quite old, because essentially started clearly with the Turing, but the idea that now are used like that. Just wait a minute. Luca, sono a fare lezione, non ti rispondo per quello. Is that based on something that is, say, inspired by the working of real neurons, and this field of research started in the 65, but the problem, just to so actually with the perceptrons, the problem is that in the 70s, essentially, or in the 80s, maybe in 70s, 80s, there was this sensation that this approach, the one that has brought to the neural networks today, was not was not the real one. So completely different things has been developed, essentially database system based on rules and languages, like for instance Prolog, and then the exploding of computing power now, for instance GPUs, has allowed to come back to the original or something similar to the original concept. So all starts with say the Turing test, which is inspired by the imitation game, which was a real game in which you had to discriminate between a man or a human. In this case, the idea is to discriminate between a human and an artificial intelligence by putting by asking a question to them and examining the answers. Actually, the inverse Turing test is what is extremely used today, is to do the same, just to discriminate in favor of humans, in order to allow them, for instance, to perform a search or to download the information. And this is the CAPTCHA, which is completely automated public Turing test to tell computers and human apart. And another approach which from time to time comes out is that of the hidden Markov model. This is essentially was developed for world recognition, but was hugely used, for instance, for classifying pieces of genome, for instance, telling apart which is the coding part of a genome, which are introns, which is essentially garbage, and so on. And so the idea is to have, the concept is to have a different Markov chains, like with very different probabilities. For instance, this one, generating strings, and for instance, these are two strings generated by these two. You can see that since I have zeros, there are forbidden patterns in the one and the other, which this is the easy way of making this. But you see that they emit the same symbols, even though they are different. So if now you have this sequence, you have to find where the most probable place where to assume that this was generated by a one process and this was generated by another process. And clearly, you need to assume that the two systems are quite different and that there is a small probability of passing from this to this, and then you can develop methods based on several approximations in order to estimate, for instance, where a garbage sequence ends and where a coding sequence ends, or where a single word in a speech ends. So this is called the segmentation of words, and another starts, because you know that if you see the plot of the sounds emitted when you pronounce a phrase, there is no breaking generally from a word to another, while the breaking are on the pauses inside the words. And clearly, you know that now we mainly use neural networks, which was inspired by this work in the 43 by McCulloch and Pitts, who developed the idea of a formal neuron, which was a Boolean device, taking a certain number of inputs, computing the product of this for the weights, comparing with the threshold, and expelling 0, 1. What McCulloch and Pitts proved was that any logic circuit, so any computer, could be built using appropriate, say, gates, neural gates, but they developed no way of building up the inverse problem. So giving some input and output, build up the circuit that will produce this output, which is the learning problem in Boolean networks, in neural networks. Another field related to this is the idea of Boolean networks. Boolean networks means having gates that could be done with McCulloch-Pitts neuron or standard gates, connected in a random way, and looking at what they do. The idea originated by a work by Kaufman, which said, okay, inside a cell you can see genes as units that can be activated or inactivated, so 0 and 1s. Each gene produces a product, say a protein, that then induces the activation or deactivation of other genes. So you can see a genetic network as a kind of gates connected as a Boolean network, so a network of gates that controls bits that in their turn controls other bits, and so on. Since all cells in multicellular being have the same genome, you have to assume that the same disposition of gates can have different activation patterns. And so what Kaufman and many other people studied was the number of patterns, I mean the number of limit cycles or fixed points of Boolean networks according to different choices of gates, and moreover, the number of genes. So essentially, the idea is to find a correspondence between the number of states, which is the number of, say, morphologies of a cell, and the number of genes. And this correlates in some way with what is observed in biology, so that the more, so the cells like bacteria, which have only one morphology or very few morphology, has little number of genes, while those with many morphologies have more, say, number of genes in a logarithm way. Clearly, another famous model is the Ising model, which each spin aligns to a local field and possibly on an external field. You have phase transitions, and based on this analogy between the statistical mechanics and microscopic models, you can develop optimization techniques like Monte Carlo, in which you find the minimum of a function which should have a kind of funnel shape at a certain resolution. So that the idea is that how you can find the minimum of this function exploiting some local information, but avoiding being trapped into a local minima, which is what happens if you just follow the standard gradient descent. So the idea is to introduce a temperature, which is the possibility of jumping over some barrier, and so that you have a probability distribution which is related to the potential by the standard Boltzmann function, and then reduce the temperature so to concentrate the probability distribution into the minimum. I said that you need to have this funnel shape form because essentially you are still exploiting the local information about the gradient, even though in an average way. Otherwise, you find just if the function is essentially a random one, like the ones that we have seen for the hash of a document, you just have to follow brute force approach, otherwise you don't find anything. Another optimization techniques is genetic algorithm, in which you, instead of just having one copy of the system, you have several copies of the system. You still have something analogous to temperature, which you now call mutation. And so you use the information coming from your pool of solutions in order to select the best ones, those that have a lower level, for instance, of a target function, and reproduce them with mutation. If, moreover, the problem is almost separable, I mean that you can represent the, see, we are working in a multidimensional system, but if the minimum of the whole function is essentially given by the minimum of different portions, sequentially portions of your coding, you can think of them like if they were genes in a genome, and then you can apply also the crossover, I mean exchanging pieces of information, by which you can jump directly to the best solution, one of the best solutions, without having to optimize all steps. But clearly, this depends crucially on how you code your system. Okay, now coming back to networks, you may ask how to introduce learning in this system. One way clearly is that used by simulated annealing and genetic algorithm. I mean, varying the system with a certain target function that can be the discrepancy between the elaboration of your input and the suggested output, and having them optimized. And this was, for instance, done by Stefano Paternello, in which he took a network of logic gates or McCulloch-Pitts neurons, connected in a feed-forward way, then feed the system with examples, for instance, how to add two 8-bit numbers, compare the output of the system with the set of examples that the training set, then vary some of the parameters of the game, connections, functions, and so on, and accept them or not according to a simulated algorithm method, or you could use genetic algorithm. And then finally he found that he was able to build up the right circuit, producing the right answer, clearly with a lot of time in order to optimize the system. And there are interesting considerations that according to the number of neurons, you can have this is the same as in neural networks. With a few neurons, you have just memorization of the patterns that you feed without any generalization, while if you have enough neurons and a large enough number of examples, you finally have generalization, so learning of rules instead of learning of examples. And but the path to neural network started with the Hopfield model, which was directly inspired by the working of neurons. I mean, the idea is to reinforce the connections among neurons that fire together. This was an integrated method model in which neurons do not fire but are activated or inactivated, minus one and one. You can show that if connections among neurons are given by the patterns that you want to store in your recurrent network, then this is actually is a minimum also of this energy defined in this way. The problem is that when you try to store new patterns, at first you have the right memorization of patterns. So the memorized patterns are the minimum of the network. But after a certain point, soon, so immediately, it also spew not wanted the minimum appear due to the correlation among patterns. At a certain point, this false minima becomes more have a lower level of energy with respect to the desired ones. So essentially, when you perform retrieval, you find combinations of your input instead of pure stored inputs. And for instance, instead of having this, if these are the stored patterns, at a certain point you start to retrieve combination of patterns. And the problem is that the storage capacity of this network is a small fraction of the number of neurons. So for having a lot of stored patterns, you need to have a huge number of neurons, which at that time was considered not good. Clearly, the other approach was to use feed-forward networks. So just with just one layer, you have the perceptron, which is able to discriminate, so to perform a linear separation of tasks, of examples. So it could say characterize or classify things in two different sets if the separation with respect to some characteristic, some input is just linear. But if you combine several layers of perceptron, then you are able to separate things. And this is the origin of neural networks. And what was essentially discovered after a while is that clearly you can have deep networks with a lot of powers, but clearly you can use a supervised or unsupervised learning, that the network, for instance, with just one hidden layer, in principle is able to approximate any function. But actually this is not what you want, because you want a generalization. So you don't want a network to learn just the examples. Essentially, if you just want this, you have a single neuron that is activated when the pattern is one of the stored pattern, and this forces the output, and so all the others are zero. And so essentially, the idea is that it can approximate any function, because any function can be divided into slices, and you have a neuron recognizing the pattern that identifies this slice and give the response assigned to this slice. But this is not what you want. You want to furnish a certain number of examples and having the network generalized. And this was quickly recognized to be related to the architecture of the network. So different architectures give different performances because, for instance, one of the simple, let me skip, architecture is the autoencoder. So essentially, you give examples, you force the system to pass through a bottleneck, and then you want that your target that the output be the very similar or the most similar as possible to the input. So to represent the identity function, but with a bottleneck. This means in order to be possible that this internal portion has to categorize the examples according to a few number of characteristics. And this is the essence of learning, how to abstract from the details of the input in order to extract only the succinct description of the input, able to reconstruct this. So, for instance, if these are faces, you may have here something related to color of eyes, has it bird or not, is it fat or thin, and so on. This is the idea of autoencoders. And clearly, then you can, for instance, impose local connections on your network in order to reduce the number of connections that you need, and so speed up the system. Clearly, the problem of convolutional neural network is that they are much more sensible to small details than to the general framework. So, for instance, they are quite able to recognize an elephant because examining the skin of the images with respect to the full picture. So if you draw an elephant using a tiger skin, humans quickly identify the elephant, while neural networks identify a tiger, convolutional neural network. So clearly, you can mix all things together. Another important point is the generative networks, in which you have actually two networks. One trying to produce something according, for instance, an image according to a description, and the other trying to discriminate between a constructed image and a real image. So suppose you have a certain database of images with description, then you can have something that uses a part of the stored image in some sense to construct a new image given a description, and something that tries to discriminate between the generated images and the real images. And clearly, when the generating part is able to trick the adversarial part, it means that it is generating good things. Clearly, the problem is that you generally use convolutive networks in this phase. This means that they pay much more attention to particulars with respect to the general frame. So, for instance, this is why, essentially in the old image generated by artificial intelligence, you see, for instance, people with too many fingers, because clearly they know how to draw a finger which is, say, very similar to a real one, but they are not counting how many fingers a human has to have. Then clearly you can have unsupervised networks, for instance, competitive interactions among neurons, so that if one is excited, the others are inhibited, or and then the final one is attention networks, like a chatGPT, in which you have a kind of mechanism that tries to raise attention to the important part of the network. This has been developed in order to solve the problem of relating a distant part of the, for instance, of a phrase, because in general you can you need to have, for instance, concordance of number, of gender, in words that can be quite separated. And so the idea is that of having a mechanism for, say, putting attention on some aspect of the system and not just on what is immediately before. And so essentially this is how to write down, to produce, but I'm skipping all of this because we are almost at the end. An important point of this attention and sec to sec, so transformers essentially, is that in this way you can easily parallelize the task of producing the output. And so this can be implemented in a vectorized way, and this is essentially what make them efficient. So this is the famous way on which you take your input, you extract attention, and then you may feed something to the other network in order to have the input from the first one. For instance, in order to this was essentially devised to make automatic translation at first. So the idea was to extract from one language the concordance of words, and then to feed this attention part to the network that was translating word by word using a kind of dictionary, for instance, in order to impose the concordance of the same words in the two languages. And okay, just for finish, I want to show you how the time needed for different services to reach 100 million users. So you see that something like Spotify, I think, in the 2008 needed 11 years, Netflix 10 years, Airbnb 8 years, X, Twitter 5 years, Facebook 4 years and a half, Dropbox 4 years, WhatsApp 3 years and a half, Instagram 2 years and a half. This is don't remember what 9 months, and finally ChatGPT just 2 months. So you can imagine what will happen in the future. And just for saying you goodbye, I would like to let you see this old video clip for the Lambo wallet, which has been built using a kind of fake interface, but this is just to appreciate what in the, say, 20 years ago would be a public image of an interacting interface which was built up, say, using pieces, but not really working interface. So you see that there is any things that we can still have, but for instance, no framework menus. So this is the idea of how people felt internet, the web interface would be in the 1994. Okay, so I think that this is enough for this course, but clearly I am available for questions. We have still a few minutes if you want. Let me know if there are comments. This is a poetry by I don't remember who, the text. I mean, the poetry by The Silhouette by Oscar Wilde. Okay, that's all. Do you have a question, comments? If not, I say you goodbye. So please sign the form and have a nice day.
Grazie, grazie mille.
Bye bye.
Arrivederci.
Grazie, bellissimo corso.
Bene, bene.
Grazie.